What's going on, guys? Wanted to fire up the camera and show you this little tool I made. It's nothing too mind-blowing or revolutionary or anything, but I figured some of you guys might be interested in it. Maybe it'll give you some ideas for your own needs. But basically what this is just a real quick and dirty little edge finder. So what it is, it's just a 1/2 inch piece of square aluminum bar stock. I cut really to more or less a random length. I think maybe it's about, I don't know, 1.25 inches, 1.5 inches. But went ahead and milled one side of it to where this is just at 100,000 thick. So nice even number. Then I've got a hole here for my touch probe banana plug, which is this guy here. Now this is just like a triple edge finder knockoff that I made. I actually plan on buying Bill's product. Bill Griggs is the gentleman who kind of made this design popular. I don't know if it's his creation or if he just started making them. But basically what this is, he calls it a triple edge finder. You got one corner here that you can center up in the circle, your bit. So I'll show you here just before we get into the edge finder I made. This is a Mach 3 plug-in screen that I downloaded. I forget which one it's called. I don't know, is it hybrid CNC plugin? I have no idea, but I downloaded this a long time ago because it works with the triple edge finder, and I made one similar to that. But down here, it's got basically your touch tests. So you've got Y positive, you can find a edge in the positive direction, Y negative, negative direction, X and Y is the same thing. Then you got this crosshairs where basically you lower your bit or probe that you're using down into the middle of the circle. You hit that crosshair, and basically it goes X negative, X positive, Y negative, Y positive, and centers exactly in the middle of that circle. Or you can use these edges as kind of a quick edge finder too. These butt up to one side, and you can kind of see how they're more or less the same point. And that zeroes the edge of your probe. So if you got, say, a 1/4 inch flat end mill that you're trying to center over the edge of your work, basically you would zero to this and then move it over, half of that end mill's width, or 1/8 of an inch. Which is kind of the same idea with this guy. And you can see I put a magnet in here. That's more or less for me, just to kind of keep track of it, so I could set that somewhere on my CNC and not lose it, hopefully, not think it's a piece of scrap, which it kind of looks like. But yeah, kind of the same idea. So we're going to be using these positive Y, positive X touch tests. I've got a 1/8 inch downcut spiral fluid end mill here, which is very sharp. I already found out, ran my finger right under it like a dummy. But I'm interested in finding the corner of this fixture plate I made for a product that I'm trying to get together here. And whereas I normally use this guy to find the lower left origin of a piece, usually this is on flat raw stock. Now, because of how this is shaped, you got kind of topography there. I really can't use this. I can't center it up. If this were, deeper, I suppose I could. But there's really no good way of making this work. So that's where this guy comes in. Now, it's not the most elegant solution. It probably would have been better if I made it a little bigger or a little more to grab onto, but it is what it is. So basically we're going to put this here. Now I'm going to find basically my X0. So we're going to get this relatively close, make sure I'm going to line up. And first I'm going to touch, make sure my probe's lighting up. You can see that little green box flashing. Always want to double check your probe, because I've had a few instances where my wire came unplugged on one side, or something happened and I ended up breaking bits, or damaging my edge finders and stuff. So now I'm going to hit positive X. Okay, now it basically just zeroed the edge of this 1/8 inch end mill. Not to this edge here, but this edge minus 100 thousandths. So it basically zeroed it to this. So what I need to do is I could show you that in a moment. I need to go to the MDI on Mach 3 here, and I need to do the math, half of that bit minus the 100 thousandths to truly find my zero. But now, before we do that, I'm going to zero my Y. So I'm going to go over here. I'm going to hit Y positive. Okay, so X and Y are basically zeroed to the edge of that end mill, again, minus the thickness of the edge finder here. So if we go to MDI, we're going to go, let's do Y0, X0. And I don't know if you guys can tell, but it's kind of off the side there. So I need to go 100 thousandths plus half the width of that end mill to put the very center of that spindle over the edge there. So I'm going to go X 0.1 and then 0.6. Or sorry, I don't need to do the O. 1.625, because it's an 1/8 inch end mill, so I'm taking half of that. Half of 0.125 is 0.0625 plus the 100. So I'm going to hit enter. So now I'm right over the edge, and I'm going to re-zero my X. Now I'm going to do the same for Y. Y point. Gotta click on that again. Y 0.1625. And now I'm going to re-zero. Now you guys can maybe see. Go a little faster. That basically I'm right over the top corner, so that's my zero origin, exactly where I need it to be. Now I can basically go to my other touch probe. And I normally add a couple layers of tape. That's about, I don't know, like 6 or 8 thousandths at the most. Because I like to cut a little deeper just to give myself a little more allowance, so that tape raises it up for me that much, if that makes sense. But I put this guy here, and now I can find my zero relative to my spoil board. So with that 0. You always want to double check. This is a brand new end mill, but make sure you don't have like glue or masking tape all over it. I've messed up a couple probes that way, or end mills. But basically now I'm zeroed to my spoil board. I'm zeroed to the corner there. Now I can set my Z height exactly where I need it to be based on the program I'm running, and everything's good to go. So I don't know, maybe that helps you guys. Hopefully you understood it, what I was trying to say. I'm not always the clearest. But just a real simple little tool you can make out of scrap. Again, the magnet's an optional choice just to kind of help me keep from losing it. It's going to go right here so I know where it's at. But yeah, just a quick and easy way to find, like on a regular fixture plates, kind of your Z0. Now, I think there is another way you know, if I find my machine zero, I can make like a, you know, G-code number that'll send me to this exact spot every time. You know, that's an option, but this I know is dead on accurate, you know, to at least, you know, a thousandth or so, if not better. So I'm a little bit happier with that, and it doesn't take very long at all. So that's it, guys. Figured I'd just show that to you. I know it kind of ran on a little bit long, just showing the whole process, but hopefully you'll learn something, or at least get some ideas for your own CNC machine. Something even quicker and dirtier than that, if you just have a thickness gauge or like a shim, maybe you have some feeler gauges, you could take one of those, you know, get a little alligator clip that goes on this type of thing, or that plugs into your probe input, and then you could just clip it onto that feeler gauge and, you know, do the math that way. You know, but this is something, like I said, I can keep it magnetized to my machine. I know where it's at. I know that it'll work. I know what the thicknesses are. And if I really wanted to, I could probably write a script to make this even more easy to do. But, you know, who's got time for that? So just throwing that out there, give you guys something to look at, think about. Thanks for watching, guys. We'll see you.